I want to talk about setup time and hold time for a flip-flop. So I will use D flip-flop for the example. It applies for other flip-flops as well. So this is a D flip-flop, the D input, Q inputs, outputs, and clock signal is here. Now setup time and hold time, these two are related. These are two are the timing constants of a flip-flop. So these two are related with the clock edge. So I will demonstrate first with the ideal clock, because usually the signal is not ideal, because we draw signals like this, but they actually go like this because the transition doesn't happen instantaneously. So anyway, first I will talk for this signal. So maybe I will erase the whole thing and then I will draw again. Let's draw the clock signal first. So we are talking about this one is a rising edge clock as it shows here. So we have a clock signal, let's say like that, and these are the rising edge where the clock works. Now what setup time says is, the when the clock changes from that, before that for a certain time the input cannot change. So the input has to be constant for a certain time before the clock changes. So basically what I will show is, let's say this is one, maybe I will use a different color. So this is a D signal like that. It changes maybe here again and goes like that. So this is a D input. This is of course 1, this is 0, and this is our D. This is of course clock here. So what setup time says is, this is the edge. These are all the edges of the clock where the clock works. This is as well. So before that there is a certain time up to the edge, where the input cannot change. So this time is setup time. In effect, what happens is, during this interval the flip-flop takes the input. It accepts the input during that time. So if the input changes during that time, the output becomes invalid because it cannot take the input. It cannot accept a valid input basically. So let's say this time is very small. It's usually in the nanosecond range, of course. So what happens is, let's say another signal, another input signal we have, let's say like that, where, so we had for the previous one, I don't know if that's the color. So this is our TS. So up to there, this is the rising edge of the clock. So that's the clock edge basically, and this is, so up to here we have TS, T setup time. So if we have a different signal which changes during the setup time, then the output becomes indeterminate. So the input becomes invalid basically. That's why it doesn't work. So this is very simply saying this is the setup time. This is what setup time is. So I actually made this video long ago, but the audio quality was terrible. So I got a request to make this video again, but I'm making it this one short. Just I'm talking about the very concisely I'm trying to talk about it now. So this is setup time. But what happens in practical diodes, the clock edge is like this. It goes like that. It is never 90 degrees, never instant. It never changes instantly. So if we say, so what happens is, here we know this is the edge. Here, so we can say this is the edge. This is right at that time, that's the edge. But when it is like that, we can say, so what we do here is, we say when it's 50%. So that's 50%, that becomes our edge. So for this this type of clock, and if clock is like that, input signal, all the signals will be like that. So the input signal is also say like that, maybe like that, it changes like that. So then we also say the 50% here. So the 50% of the input signal and the 50% of the clock edge has to be more than the difference has to be more than setup time. So that is setup time. Now if we talk about hold time, that's exactly the same. It's only after the clock edge comes. So after the clock edge comes, how long the input cannot change. So if the input changes before that, then again the input becomes invalid. So the output becomes indeterminate and input becomes invalid. So let's talk about that in the same diagram. Let's say this is our hold time, which is after the clock edge. So it can be different from setup time, usually it is. So let's say, arbitrarily speaking, this is our hold time. So then this is hold time, and within that period the input cannot change. So this is our invalid input. Similarly, for this first input, if we call, I don't want to name it anyway, so this input is valid because this is satisfying both setup time and hold time. It is not changing neither here nor here, so that's fine. And this one is changing, this input is changing, it is not satisfying setup time because it has changed within the setup time. Now if we try to demonstrate another input which is changing within the hold time, that can be like this. So it's a red one I am drawing. Let's say another input, it doesn't have to be from 0 to 1, it can be from 1 to 0. So let's do that. This is 1, this is fine, it is satisfying setup time, but let's say during hold time it changes. If that happens, because this time is hold time and it has changed during hold time, so this input is also invalid. So this input is also invalid. This is failing the hold time, and this red one is failing the hold time, and this violet one is failing the setup time. So similarly for hold time as well, this will be 50%, and if it changes here, 50% after. For practical case, this is also not instant, so we will have to just it will have to just satisfy the 50% of the edges basically. So from the 0 to 1, it's going from 1 to 0 here. So whenever it's up to 50%, if that point is more than hold time of the clock, for the clock signal, then it will take as a valid input. So instead of basically, so for here we could just say this point, but for this one it's the same concept, only the point will be 50%, because here we can say that which point, this point or this point or which point. So this is just a 50%, so just in the middle basically. So basically setup time is the clock signal is like that. Setup and hold time, if we talk about them together, the clock signal doesn't allow the input cannot be changed during the clock age, from the clock age, a certain time before the clock age and certain time after the clock age. Within that range, if we say, the input cannot change. So basically the clock, the flip-flop takes a while, though after the clock comes, before the clock comes and after the clock comes, the flip-flop takes in order to accept its input, we can say it this way, that it takes a while, and that range, instead of being right at that point, or for this one right at the middle point, there is a range of time, we can say. So that range is, before that is setup time and after that is hold time. During that time the input cannot change, it has to be a certain value. It can change before that or after that, then it doesn't matter, because if it changes before that, whatever input is here will be taken as, so if it changes here, let's say it will taken as 0, let's say it goes like that. And if it changes after the whole time, it doesn't matter, because the clock has already accepted the input. So it is, while it's accepting the input, before it's accepting and after it has taken the input for a certain time, the input cannot change. The input has to be constant during that time. So those times are setup time and hold time. So yeah.